And this is exactly what we're going to talk about in the next panel. For that, I'd like to ask Timothée Moulinier, Simon Anink, Sylvain Faguet, and Philippe Davignon to join me on stage. Good morning. With a microphone, please. Good morning, everybody. Hello. So, Timothée Moulinier, you're a R&D delegate at France's Maritime Industry Association, GICAN, and your organization has been taking stock of how the French maritime sector is trying to bring down its emissions. What have you found out?
Thank you very much for welcoming us here. And again, as it was just mentioned by Antoine Robin, it's like all the need for decarbonized ships is critical. All sectors are concerned, deep sea, short sea, ferries, and so on. But there is a special case a bit for renewable offshore energy, as the objective is to develop a decarbonized world. So I think there is a bit ethic or moral pressure on your sector, on our sector, to also lead the way to decarbonize the ships we are using to install decarbonized sector. And so what we have done so far, and this is the next, I don't know if I can change it.
There you go.
Yes, is we worked hard at a French level in order to identify, and this I think is a common understanding about all what has been done through with the ship owners, with ports, with everyone, about the main lever for maritime decarbonization. And what we have found out that there is several points that we can do. One of them is really at the design of the ships. It's like how to, within the ships, bring all the technology we see in order to have a very good use of the energy on board, to have optimal design from the hull to propulsion to all what we can do inside. And this is the first lever. And with this, the shipbuilding association that we are and the equipment manufacturer are there, and one of them will be with us today on this. And once it's design, then there is a need still for energy on board. And the second pillar is really what type of energy we use. And here again, you have all the different low carbon energy that could be available in order to reduce the carbon intensity of the energy we use on board. And so here there is a place for electricity, there is a place for fuel, for hydrogen, for wind energy. I think we have it's unique in all the means of transport to have this energy of wind for long distance, for short distance, so it's a specificity of our sector. And then once it's not possible to get rid of all the emission, you can capture on board, on special ships, on different types of ships, it's critical. And this is the full part. And the second part is really, even though, once we have all done this, at operation level, what we can do. And here we have, with the help of digitalization, and I think the eyes here could really also emphasize this, is like how we operate our assets to have the less and less. And what we see at the French level is that there is more and more offer on this through digitalization, with help the seafarer on board, help the operators, help all the ship owners to minimize their imprint with this. And after, what we can say, what we have done so far is, based on this common agreement of all the levers, we have consolidated a panorama of all the French industrial solutions. And so far we have put together more than 360 solutions carried by more than 220 French solutions, French industries, companies. And so it's available at a free, in our website, so that you can say, and in our booth we can discuss it and go into the details of what we can do. It's available. And a bit based on this, what we can see also is that still the ships is very critical, as we say. And here, at the French level, we have really an offer ranging, as it was mentioned, for various part of it. So going from the survey that needs in the preparatory work, going from guard vessels, going from tug, going from CTVs, crew transfer vessels, and so on. And here, I think our shipyards are already ready to work with the operators and the ship owners on this. And what also we can carry as a message as a GICAN is like we also think that this question about how we use the infrastructure and why we use the ships can also be challenged with the new technologies that are brought forward with our industries based on AUVs, on drones, on sensors, on smart sensors, on all this can also reduce for the same services. So here we are already talking about efficiencies from the same services, the need for inspections, needs from data, needs from whatever. I think here also there is a place for those new equipments, those new parts that can be done. And maybe I think this is key. But maybe what I want to also stress is the difficulty for all those solutions, either decarbonization solutions, either drones and so on, is to the deployment phase. So far, we have done a lot of research, a lot of development, and now all those technologies are ready to be implemented on ships, on the offshore farms and so on. But we need to go there. And here, what we see as a hurdle is to share the risk. And we believe this sector of offshore energies is, by nature, as I mentioned in my introduction, the one that could show the case for other sector, historical sector. And for this, what we need is the visibility of the need, visibility of the business, share the risk, share the cost, share the extra cost of decarbonization, but because there is an extra cost on decarbonized ships, and for this, the long-term vision can help us. So we can see that maybe spot market for installation is a challenge. It's like how much the operators are ready to pay for 2, 3, 6 months, even 1 year project. But on the long term that was mentioned, the exploitation phase, the maintenance, here is a long-term contract, and here there is a lot more room to work for business case. And I think this is a bit the message, is like the French industry is really ready to carry out all those technologies with all the partners that are present here. Thank you very much.
Thank you. Thank you very much. Simon Anink, you're from Netherlands, Netherlands-based maritime services provider, Acta Marine. You're the general manager of commerce at the Rotterdam office.
That's true, yeah.
Good morning.
Thank you for having me. Good afternoon.
Thank you, good afternoon, yeah, that's right.
We are an operator of walk-to-work vessels that assist our clients in the wind farm for commissioning purposes, for commissioning activities and O&M maintenance. And we've been looking at our designs, of course, like everyone, how to make them more green, mostly at what type of e-fuel will develop over time. And that's, we have currently 4 vessels under construction at a Turkish shipyard that is incorporating technology for making them ready for receiving e-fuels in the future. We're also contributing hopefully there. It's a little bit of a bet, of course, where this will move, but yeah.
And so I understand you've got different ways of bringing down emissions. One of them is redesigning vessels. You've been integrating batteries, and you're talking about e-fuels. Can you tell us a bit more about the details?
Yeah, we have, these vessels that we operate mainly are in station keeping mode, which means that they're on DP. And so we've been optimizing with the new current designs the way that they operate in the field to make it more symmetrical, more efficient in that sense. And as I just mentioned, the big step forward is to redesign the propulsion train and make the systems suitable for receiving e-fuels in the future. So that's where we put our bet.
Right, e-fuels, and what is that? Electrical, fully electrical boats, or is that also in the card?
Yeah, that's also what we're looking at, but in this case we're looking at, for us we put our cards into the methanol box, so we will be able to operate these vessels both on diesel as well as on methanol in the future. So that's dual fuel methanol technology. And the reason for us to do that is that the technology readiness level for methanol is fairly high. So, you know, especially the offshore industry has been accustomed to using methanol for many years for other purposes as a good to be transported. So the technology is there. And secondly, there's a clear pathway for us from today, you know, to let's say 2030, where hopefully green methanol will be more available or more abundantly available than is currently the case. And that's by biomethanol. So biomethanol is a good that's already available. It's not as low carbon as green methanol, but it's still a big savior compared to diesel. So.
All right. Well, thank you so much, Simon Anink. With us is also Philippe Davignon. Good afternoon.
Yeah, hello. Good afternoon.
Hello. You're the commercial director of Rochelle-based Genevos that is putting something else on the table to bring down greenhouse gas emissions for vessels.
Yeah.
Your startup was founded in 2018. You now have 10 employees. Tell us a bit more about your technology.
Yeah, absolutely. Yeah, good afternoon, everybody. So we are indeed based in La Rochelle on the west coast, and we have been developing a full modular and integrating the hydrogen fuel cell system. So we are definitely, let's say, on the marine side, let's say, to bring a plug and play and modular zero emission solution based on hydrogen. So we have developed a complete range from 40 kilowatt to 250 kilowatts that can be scalable to multi-gigawatt systems. So basically we can offer these solutions from very small vessel, passenger vessel, up to big working boats, including CTVs, SOVs, offshore vessels, whatever.
And I understand you've provided your hydrogen module for 6 boats so far, with one more coming up. And at least that one will be deployed in the offshore wind energy sector,
yeah.
right?
Absolutely. So today we have 4 vessels already equipped. We have 2 in project right now on some specific harbor vessel and fishing vessel. Fishing, which is also a very big, let's say, some big discussion around decarbonation for the future. And we are also indeed included into a CTV vessel, so this crew transfer vessel, bringing technicians and material for the maintenance of the wind farms, where we propose a 800 kilowatt hydrogen system on board a specific vessels. With hopefully normally a first boat on the water, normally let's say between mid next year to end of next year. Yeah.
CTV vessels is also a market where you'd like to expand, right? There are more projects possibly coming up.
Yeah, absolutely. The CTV is definitely a very good vessel for us because hydrogen, one of the main points compared to methanol is that the hydrogen, let's say the power density is a little bit complicated. It means that it's taking a lot of place on the boat. So definitely our market is more to what we would say, let's say, harbor vessel or short sea vessel. So CTV is a very good example. Also because CTVs is working for, let's say, zero emission electricity generation, so makes some sense also to decarbonize all this fleet. Yeah.
I think you brought one slide, is that right?
Absolutely. So this is a harbor boat that will be delivered next year. It's a 40 meters harbor vessel for Northern Europe. And on the left, so you can see our module, which has been basically designed and developed to be the most plug and play as possible. Yeah.
Right. I understand this is not a solution for the whole maritime transport market, right? There's a specific niche for it.
Exactly. This is also what's really interesting into the maritime sector, because today the marine sector is using mainly one type of energy. And what we know tomorrow is that it will be many different energies. We are talking about methanol. We are also talking about ammonia. Let's be honest, fossil fuels for very large ocean-going vessels will be still there. But there will be also a place for hydrogen and for full electric. So between 2030 to 2050, we see a bunch of a wide range of different energy vector, including hydrogen, and that's good. So, and that will be placed basically for any kind of technology as soon as it brings some advantages in terms of decarbonation.
All right, well, thank you so much for that overview.
Thank you, Lisa.
Philippe Davignon. With us is also Sylvain Faguet. Good afternoon. You're Chief Sales Officer at Nantes-based, now I'd say DICE. Is that right? DICE?
DICE.
DICE, there you go. And you're aiming to bring down greenhouse gas emissions by optimizing maritime routes. Is that right?
That's right, but actually we work on weather routing optimization, which is one lever to reduce the fuel consumption of vessel. But we are not only working on this, we are actually working on operational excellence. We have developed a complete navigation and control system to help the crews plan, optimize, execute, and analyze their navigations. So we have a complete system with weather routing, which is a good mean to reduce the consumption, but also advanced autopilot and dynamic positioning system. As mentioned, Simon, it's very used in the energy sector. And so we are a young company based in Nantes, and we are gaining parts of the market on this sector.
I understand your technology is so far not deployed in the offshore renewable sector, but it could be in the future.
Definitely, our own technology is not yet completely on the sector. DP technology have been here around for many years, 60 years, but in the last 10, 15 years, they have not that much evolved. Ship owners, naval architects, they have worked a lot on the hull design, as mentioned Simon, but not that much on the core of those technologies, and we are providing advanced approaches to reduce the consumption of the DP systems. We are also working on the weather routing, which is more interesting for long voyages, and it is more used for logistic parts of these jobs.
I was wondering actually, because you're mentioning long voyages. Does your system, does it make sense in the offshore renewables market where the distances are relatively short?
They are short for the installation and operation and maintenance, but for joining the construction sites to for example, the parts fabrication sites to the offshore site where they would be installed. There we have to mobilize assets to transport, as mentioned Antoine also, to transport the jackets, the monopiles from Asia to Europe very often. On that specific voyages, there is a lot to gain in terms of optimization.
Talking about clean technologies and maritime transport, these have been around for quite a while, actually, I think for centuries. Why has that not taken off yet, that market?
You are correct. By green technology, we name wind propulsion. Of course, there is some new fuels, but the idea also is to reduce the needs for fuel, and we can use the wind, which is already available. As you mentioned, there have been technologies that have been existing for a while. The first rotor flattener has been installed in 1920s. The first suction wing has been used by the Commandant Cousteau in 1960s. So we start to see again those technologies. There is some example in the renewable sector. For example, the E-Ship 1 vessel, which is fit with the 4 flattener rotors, has been transporting blades for wind turbines. So it's a first step, let's say. There is also some heavy lift submersible vessels that have been equipped with such systems also in China. So we see these technologies coming back, and us as an engineering consultancy also, we provide studies, and we have been involved in some studies to evaluate the benefits of using such technologies on offshore vessels. Wind assistance system developers are working at movable systems, containerizable systems, in order to be installed on deck to equip any vessel. and that would be a few persons to gain to improve again the consumption of vessels.
All right, well, thank you so much. Thank you,
Thank you.
everybody, for your insight, and thank you for listening.